Okay, so today we are going to talk about more points, lines, and planes, and diagrams, and things like that. But before we do, I want to review the law of syllogism again. There's a couple things I want to point out. So we're going to use the law of syllogism in this pair of statements to write a new statement. So the first statement says, if it is Tuesday, then you mow the grass. And then the next statement says, if you mow the grass, then you water the flowers. So it's really important that these are exactly the same, and that's when they can cancel each other out. So then our new statement is going to be, if it is Tuesday, then you water the flowers. Okay. So again, the thing I wanted to point out is that it is really, really important that it's exactly the same. Okay? All right, so we're going to move on, and today we are going to talk about some postulates using diagrams. So points, lines, planes. So first we have the 2-point postulate. And what this says is through any 2 points, there's exactly one line. So it doesn't even matter what the 2 points are. If there's 2 points, there's exactly one line that goes through that. Okay, just one line. It doesn't matter where the 2 points are, as long as it's just 2 points, we can draw a line through them. Okay? The line point postulate says that every line contains at least 2 points. Okay, so there's more than 2 points, but every single line has at least 2 points. Okay, the line intersection postulate is that whenever 2 lines intersect, there is exactly 1 point that is their intersection point. So if these are the 2 lines, they intersect right there. If this line and this line intersect, right there in the middle, that's their intersection. Okay, so there's always 1 point in the middle that intersects. Okay, the 3-point postulate says through any 3 non-collinear points, and that's super important that it's non-collinear. If they're collinear, this isn't true. Okay, so any 3 non-collinear points, there exists exactly 1 plane. So if I have this point, and this point, they're non-collinear, so there's 1 plane that would go through those 3 non-collinear points. Okay. The plane point postulate says that a plane consists of at least 3 non-collinear points. So it's kind of going backwards from the 3-point postulate. So if there's a plane, then on here we can put at least 3 points that are not in a line. And that's what that plane point postulate says. Okay? The plane line postulate says if 2 points lie in a plane, then the line containing them lies in the plane. Okay, so it's basically taking this plane and saying, here's 2 points on the plane. The line that goes through those is also on that same plane. Okay? And then if 2 planes intersect, then their intersection is a line. So if I have 2 planes, oh man, my plane drawing skills are not ideal. That their intersection is a line. So anytime 2 planes intersect, it's a line. I've kind of talked about this before, but if you think about like 2 sides of a cube, when they meet, it creates an edge, which is a line. So that's the plane intersection postulate. So this is kind of formalizing some things that we've talked about before. Okay? So now we're going to look at each of these diagrams and match them with one of those postulates that we just talked about. Okay, so what I see here is I see some points. So if there's some points, and then we draw a line through those points. Okay, so even though there's 3 points here, this is actually the 2-point postulate. Okay, and that's because we have 2 points and there's 1 line going through them, and they're all collinear. So even though there's 3 points, they're all collinear. So it's the 2-point postulate, okay, because we're not drawing a plane through points or anything like that, okay? So then moving on to the second one, I see a plane and I see 3 points. And then in the then part, I see there's a line drawn through 2 points that are on that plane, and the line is also on the plane. Okay, so this is the plane line postulate. Okay, and that's because I'm taking 2 points that are on a plane and drawing one line through them that is also on the plane. Okay. This next one, I have these 2 lines that are intersecting, and then I see there's this point right in the middle. It's kind of hard to see. It's gray, and it's an intersection point. Okay. So this is the line intersection postulate, because 2 lines are intersecting and their intersection is exactly 1 point. Okay, this next one, I see there's 2 planes and they're intersecting, and then in the then part of it, I see that there's a line drawn where those 2 planes are intersecting. So 2 planes intersect to create a line. So this is the plane intersection postulate. Okay. All right. So this next, I would like you to pause and try to answer yes or no for all of these real quick. Okay, once you've unpaused, I'm going to look. Can I look and see that plane A, so this gray plane, and plane B, the white plane, intersect at line EF? And I would say yes, okay? Because when 2 planes intersect, it creates a line, and in this case, that line is EF. Okay? Points C and D are collinear. Now this one's interesting because I don't even really need to see C and D to say yes to this, because any 2 points have exactly 1 line that goes through them. Okay, so that's the 2-point postulate that tells us that C and D are collinear, because any 2 points are collinear. Okay, and then we're going to look here. HJ and ID are perpendicular. The answer to this is also yes, because perpendicular means it creates right angles, and we can see one here, and then that means that this one is also a right angle. Okay, so they are perpendicular. All right, so let's look next. We have GD is a bisector of EF at point D. The answer to that is also yes, we can tell that, and that's because of these little lines here that mark, that say that ED is congruent to DF. Okay, if those little lines weren't there to mark that those 2 pieces were congruent, we could not say that it was the bisector. But we know that it is the bisector because those 2 marks are there. Okay, the next one is IH is congruent to, I'm going to add the congruent because that makes it a little bit more mathematically correct. IH is congruent to HG. Okay. Well, it looks like it. I mean, IH and HG look about the same. And I know that JH is perpendicular. You know, there's not enough information. I would need some sort of marking or some sort of information about JH being the bisector or something like that. But the answer to this one is no. There is not enough information. We need more information to be able to say that IH, segment IH and HG are congruent. Okay. The last one here, HJD, so this angle right here, and HDJ, so this angle right here, it's saying that they're complementary angles. So let's go think back. Complementary means they add up to 90 degrees. Okay. Well, I don't see any markings there, but I do notice that there's a triangle here. And what do we know about the angles in a triangle? Triangle always adds up. They always have a sum of 180 degrees. Okay. And we do know that this angle here in the triangle is a right angle. So we know that JHD is 90 degrees. So we know that these two have to be complementary, because if we add them together, they should equal 90. So the answer to this is yes. Okay? All right, so today was a lot about postulates, and okay, so there was a lot of information today. Those are all on the guided notes page that I posted when I posted this video. Okay, and so today I want you to take those notes and have all those postulates, that list in front of you, and I want you to complete the 2.3 Big Ideas assignment. Okay, it is all about 2-point postulate, line point postulate, line intersection postulate, 3-point postulate, plane point postulate, plane line postulate, and plane intersection postulate. That is a lot of postulates to remember. So again, have those notes out in front of you when you're doing this to help you out. And please let me know if you have any questions.